CMPS. Now I'm recording and let's try. Okay? If this succeeds, then I'm golden. Okay. Welcome to everybody. So we are recording already. Let me try to see the chat and let me share the screen. So what I want to do today is, for once, some slightly more advanced stuff, more interesting in a way, but also a little bit more advanced. So basically, I want to solve a problem that I have always sort of kicked back in this class. That is, what do you do about images and what do you do about files? Now, there are two kinds of images, okay? There are the images that that are static, right? That these are the images that are part of your layout or maybe embellishment so that you have on the website. And those, you can put them in a static directory, like, this would be in my start application, you have this static directory, and then you have images, and then you can put your images here, and you can then access them to your heart's pleasure. Okay, so and this is fine. But the point is really, what do you do with images that are user generated? So what do you do with images that people need to upload and download, and not only images but generally files? And so part of the story that I want to tell in these few days that are remaining is that. Part of the story is that when you design a real-world application, a lot of the work you do is in the end the memory heresy work, right? So there are many places in which you can store information. Some of it is a local file system that, in the case of web, is purely a very short-term cache because the web server may not be long-lived. Then there is your main memory. Then there are memcache servers in which you can that are like memory caches. I will get into them later. Then there are databases, but then none of these things is a really good fit for what we want to do with images, right? Imagine we want to do something like Flickr or Instagram, right? One of these things. The problem of images is that they are large, and so you don't want to put them in the database. The databases work best when you put a lot of very interconnected, dense metadata. Okay, because databases work best when they can keep in their memory, cache in their memory. You see, so CS is by and large, is a big problem of caching, right? Of making sure that the information is in the cheapest but fastest accessible place. So in a database, the database really works well when it can cache in memory a lot of the information that is written and read on short notice. So that a lot of the queries about getting your session from your cookie, etc., can be answered by memory. And it also works well when the bandwidth to it is not too high, because then the network connection and its own connection is not saturated, right? And so it's a pretty bad idea to start putting megabyte large images inside a database. What is Just putting large. Yeah. Oh yeah. No, I thought that there was something wrong with my recording. Okay. So in general, it's a really pretty bad idea to put large images in a database. Another problem of databases really is this. Right now, we're using our local, actually right now, if you upload an image, it goes in the local file system. That's not good. But even if you decided to put the image in the database, which you can do, the local database we are using is for testing. Now, if you use a real database in the cloud, you notice that there is one restriction. Whereas front-end servers, you can get any number of them based on load, because every time you need a new one is brought up to you from a sort of image. We will see how to configure these kind of things in the few next classes. The database server is always existing. So if you you have two choices. Either you run your own, which you can, but it's not something that I would advise you to do. Or by far the most popular choice, and I think the best, is to go to the Amazon cloud or the Google cloud or the Microsoft cloud and use one of their managed database services. There are various. We will tour various next week. Okay, but you notice that all of those services have some constraints. For example, I don't remember because they increased it recently. But if you go like Google Cloud SQL. I should have written something like pricing or so, okay? Where are the Cloud SQL for MySQL pricing. I don't know. They change names a little bit, so I'm not sure that I can land immediately. Second generation pricing. Okay, fine. And so there is maximum storage capacity. Okay, 10 terabytes, and so you can look at what they have and how much they cost per day, or I don't know if they have a. No, we want monthly, of course, right? And so, the prices get somewhat high depending on the storage, $3,000 a month for the storage, etc., etc. But also, there are some limits. Now, 10 terabytes may seem like a lot, but if you want to do something like Flickr, clearly you cannot scale to that. That means that the database has these SQL databases have the advantage of being able to answer MySQL queries. So the joins we have been doing so far and this kind of queries, they have transactions, so you can keep your data with a very nice, semantics in which you know that only one, you know the transaction from several users at the same time do not interfere and so on and so forth. But there is a drawback that in order to give you those guarantees, the database needs to be essentially somewhat in the same place. Then you have distributed replicas in case of failure, but essentially, if you buy one of these servers, the disk and the CPU will be largely in the same place. And so there is a constraint that you cannot easily scale more than what you can have there locally. You cannot go to, 1,000 terabytes. So you cannot go to the scale of a very large service. And so, and more than that, you're essentially paying top dollar for a database that gives you all this transactional integrity and ability to query and ability to search for something that instead you would like to use just as a glorified file system to store images, right? So it's the wrong place essentially where to store large chunks of data. The better choice by far is to store images. I mean, I'm giving you a bit of my way of looking at it, okay? So you can either, again, spin up your own service. So maybe I should have said, for many of these solutions, there are two general solutions. One is to spin up your own entire service. If you want to build your own image storage service that runs on raw hardware or raw machine images, you can, but I wouldn't recommend doing that. The best is to use, if you can, managed services that take care of a lot of the difficult stuff for you. The difficult stuff being regular backups for disaster recovery, geographical distribution, so that if there is a fire in a data center, you don't lose all your data, these kind of things, right? They're difficult to manage. And so you might as well use actually some cloud services that give you file storage capability. And the two major ones are the one by Amazon is called S3, and the one by Google that is called the Google Cloud Storage. And so today we will see essentially how to use Google Cloud Storage to our advantage for storing images. This is the topic of today's class and likely also some of Monday's class. I don't think we will finish today. There was a question? Okay. So what we want to do is something like this. So first of all, how does Google Cloud Storage work? Google Cloud Storage by and large works in this way. You create a Google project. I have many Google projects. You can create one. You simply go to console cloud google.com. There you have a list of projects that you might have. And then you can sort of pick the one you want. Let me actually pause the recording and show you a moment. How do I pause the recording? Yeah. So okay. And so in Look at Teaching, there is a storage, and I can go to the storage browser. Okay.
Hello?
Yeah.
Professor, you're using a Zoom meeting number that's different from the one in Piazza.
Oh, okay. Oh, wow. This is kind of bad. Let me stop and begin a new meeting. I don't have any other way.